$1,000 sure seems like a lot for a 3D printer. Why spend that money when I can have my parts made elsewhere and sent to me for less? At a glance, sure, that's the much better option. But there's a lot more to consider than just those dollar signs. Today, I'll be going over the ins and outs of getting parts manufactured by a third party, diving into costs, and taking a closer look at many of the pros and cons of going to another manufacturer compared to doing it on your own machine. I'm Nick with Race 3D, and this is our manufacturer versus 3D printer price breakdown. Whether you're working tirelessly at an industrial design firm, or starting a home business, or simply living your best life, sooner or later, you're going to find a need for some custom-made parts. There's more than one way to get those parts from paper into the palms of your hands. Now, there's a number of manufacturers online that are willing to take a model of your part and reproduce it in a variety of methods, but not all manufacturing methods are created equal. Two of the most familiar methods are CNC machining. It involves taking a block of material or a blank and then milling away from the block to produce the part. Injection molding requires that a mold be made of the part beforehand, typically through CNC, and then that mold can be used thousands of times before a new one needs to be made. The other methods we'll be covering are FFF or FDM, traditional filament printers like the Pro2 and E2, SLA or stereolithography, and SLS, which is selective laser sintering. But just so we're clear, FFF uses plastic filament for printing and is available in the widest variety of materials, depending on the service. SLA refers typically to resin printing, where a vat with a clear base full of resin sits above a projector screen that uses UV to cure the liquid resin and then pulls away from the screen layer by layer. There's a few types of resin available for different use cases, but currently the most advanced resins are proprietary and the parts tend to be more brittle unless using a specifically flexible resin. Now, SLS uses a type of nylon powder that it lays down in thin layers over the full build area. It lays down a bonding agent over that, and then it hits that layer with a laser to sinter it to the main part, and then it repeats with a whole new powder layer. So, now that we have all the methods laid out, we can look at the costs. Now, all the estimates that I have for production come directly from the manufacturers. I sent in this part in for quotes, and we kept it relatively simple and something that could be produced by all methods. Of course, there are parts that would be extremely difficult for one method compared to others, but doing that wouldn't be fair. So we got quotes for this part in batches of 50, as some services are more optimized for lower part production, and they won't even consider production methods for lower quantities, so I wanted a decent sample size. Now on the 3D printing side, estimates for FDM cap out at around $2,000. Again, this is for 50 parts. My cheapest quote was for 140 for the whole batch. SLA came in significantly higher than FDM with 2,100 at the lowest and up to 7,000 at its most expensive. SLS varied a bit more similar to FDM with $785 for the lowest and the highest at $3,150. On the other end of the manufacturing spectrum, we have $1,300 to $1,990 for CNC aluminum and about $5,000 for injection molding. Injection molding is unique in that, breaking it down, we're looking at $4,800 for the tooling and $300 for the batch of 50. If we went and produced more, of course, that would adjust accordingly. Now, we did have one crazy outlier too, where the quote for getting the parts made out of aluminum was $21,545. It's good to at least get a few quotes anytime you're looking, just because of that, random occurrence. Steel, on the other hand, from the same manufacturer was only about $8,920. It didn't specify which method it was using to make these parts out of those materials, but I guess it's closer to SLS than CNC. Another thing to consider when working with these manufacturers is lead time. Estimates are around 3 to 8 days of lead time for 3D printed parts and up to 2 weeks for CNC and injection molding parts, and then shipping time on top of that. But now why bother with a third party at all, right? What if I want to make the parts myself? First, you need the machines to make the parts, and we'll just say that you already have the knowledge and someone else who knows how to use them. For most capable CNC machines, you'd be looking at a 5-axis machine compared to a 3-axis machine. Now for a 5-axis machine, you'd be lucky to find a decent one under $100,000. An injection molder looks to be as low as $10,000 and up to $200,000, but the molds don't come out of thin air. So typically they're CNC machined and then injection molding. So those costs would be on top of a CNC machine. Now, CNC machining is definitely out of my budget, so let's look at the cheaper printers. We'll be using the Pro2 as our price and size baseline, so we're looking for other machines of a similar size. Looking at SLS, the lowest price sits around $10,000, but for any build volume close to 300 millimeters in X, Y, and Z, it rockets up to around 100,000. On SLA machines, the problem isn't the price. You can get a usable machine for a couple $100 and a medium machine for around 2,000. These run volumes are around 300 millimeters by 150 by 400. But to get closer to 300 millimeters in X, Y, and Z, we have to look more into a machine like the Form 3L, which is a price tag of 10,000. Plus, you can be limited by the types of materials that are available to you. Now, the last thing to consider in the cost of materials. FDM, SLA, and injection molding are the most effective in reducing waste during part production, with CNC being more wasteful due to it being a subtractive manufacturing process. In some cases, SLS powder cannot be entirely reused and needs to be mixed with fresh powder so that it does not degrade the part quality, or it may not even be reusable at all. But that seems to be the case with older machines. So, regards to this specific part, it takes 45.5 grams of material to print with 100% infill and 26.6 grams printed with a standard 15% infill. Using a material that costs about $30 per spool, we're looking at costs of $1.37 and 80 cents respectively for those two infills. Now, comparing that to our manufacturer estimates, even at the lowest cost, producing parts is still over 100% cheaper on a part-to-part basis when looking at FDM printing. So given that the cost of the Pro2 is $4,000, at the rates mentioned before, with this specific part, we would need to produce 3,000 units for the savings on these parts alone to fully pay for the Pro2 itself. Now, granted, it all depends on the part being produced, and these machines are used for making more than just a single type of part. The most effective case is for larger scale, single-use prototypes. As a real example, this part costs roughly $20 in material when printed in-house. That's $100 cheaper than the estimates I got from our cheapest manufacturer. I do want to clarify that this is for one of these parts. Now, the price will typically go down if larger amounts of parts are needed, so if we say that all the parts will be one-off productions, then the Pro2 pays for itself, in this case, within 40 prints. Now, that's using the cheapest option available, PLA material. If we step it up into nylons, the difference in prices jumps to $370 per single production, meaning that the Pro2 will pay for itself in just over 10 prints, and that's not even using the full build volume. On top of that, a few other advantages are that owning your own machine gives you absolute control over the part's construction. In some cases, third parties will only let you choose between a handful of resolutions or infill settings. There's also the lead time factor. So when producing these parts en masse with my own machine here, it takes me roughly 10 days of print time to complete a batch of 50 on one machine with 100% infill. That's comparable to a third-party lead time, but I get the parts as soon as they finish and they don't all complete at once. So rather than waiting around 12 days for 50 parts, I can have 15 made every 3 days and even every 2 days when we lower the infill. The one caveat in this case is that I do need to be there to remove the parts and restart it between batches. Given the cost of manufacturing currently, for low volume custom parts, either for regular use or single use prototyping, owning a 3D printer is hands down the best way to go. Optimized templates and ID Maker allow new users to start printing right away, but they also allow for a massive amount of customization and adjustments on parts if needed. And the scale of the Pro2 and the Pro2 Plus ensure that you won't be limited in size when it's most important. Well, that'll do it for our price breakdown video. I hope it's been helpful, and I'll see you next time.